This machine is 96 meters tall, 240 meters long, and weighs 13,500 tons. It moves at less than half a mile per hour, slower than any human can walk. And in the time it takes you to read this sentence, it has consumed 2,000 tons of earth. It has never been turned off, not once in 46 years of continuous operation. Entire villages were demolished to clear its path. This is the Bagger 288, and it is the largest land vehicle ever built. In the next 10 minutes, you will understand how something this enormous was constructed, moved, and kept running without ever fully stopping, and why nothing built before or since has come close to its scale. Germany's post-war economic recovery ran on one fuel, brown coal. Called lignite, it burns dirty and inefficiently, but it sits beneath the German countryside in enormous quantities. The Rhenish lignite field beneath western Germany is one of the largest accessible coal deposits in Europe. To reach it, engineers needed to remove everything above, meters of rock, soil, trees, and entire communities. The machines doing this work in the 1960s were already the largest excavators ever built. They were not large enough. German energy company RWE commissioned engineering firm Krupp to build something that had never existed. A single machine capable of removing 240,000 tons of earth per day. Not per week, not per month, per day. Krupp's engineers began designing a machine in a category entirely its own. The core of the Bagger 288 is a rotating steel wheel 21.6 meters in diameter. That wheel is taller than a 6-story building. Mounted around its rim are 18 steel buckets, each holding 6.6 cubic meters of material. The wheel spins continuously. As each bucket reaches the bottom of its arc, it bites into the rock face. The bucket scoops, fills, and lifts the torn material upward. At the top of the arc, the bucket inverts and dumps its load onto a conveyor belt inside the boom arm. That arm extends 70 meters out from the main body, longer than a Boeing 747. A second internal conveyor carries material the full length of the machine to the rear discharge boom. The discharge boom, 62 meters long, deposits excavated material onto ground conveyors running out of the pit. Those ground conveyors carry material up to 10 kilometers away to the power station. From rock face to power plant, the system runs without human hands touching the material. The Bagger 288 does not dig, it processes an entire landscape. Numbers alone do not convey what 13,500 tons means, so let's compare. The Eiffel Tower weighs approximately 7,300 tons, roughly half the weight of the Bagger 288. The Statue of Liberty, 225 tons. You could load 60 of them onto this machine. The Saturn V rocket that carried humans to the moon weighed 2,170 tons fully fueled. The Bagger 288 weighs more than 4 fully fueled Saturn V rockets combined. Its height of 96 meters equals a 30-story office building. Its length of 240 meters exceeds 2.5 American football fields placed end-to-end. The bucket wheel alone, at 21.6 meters, stands taller than the Arc de Triomphe in Paris. The machine rests on 12 Caterpillar track units. Each individual track is 3.8 meters wide. Those tracks distribute the machine's weight across enough ground area to prevent it from sinking. Even so, the mine floor must be carefully engineered to support its movement. One machine, larger than most buildings in any city nearby. The Bagger 288 requires 16.56 megawatts of electrical power to run. That is enough electricity to power a city of 30,000 homes simultaneously. It carries no fuel. It is permanently connected to the power grid via thick electrical cables. Those cables travel with the machine as it moves, extending and recoiling on large cable drums. The onboard system distributes power to dozens of motors throughout the structure. The bucket wheel drive alone requires 3 megawatts. The output of 3 wind turbines running at full capacity. The machine is monitored from a control room located inside its main body. A crew of approximately 5 people operates it per shift. 5 people, controlling a 13,500-ton machine actively eating through bedrock. The operator adjusts wheel speed, bucket depth, and advance rate in real time from the cab. Sensors throughout the structure detect overloads, vibration anomalies, and stress concentrations. In 46 years, no critical structural failure has permanently ended an operation. Moving the Bagger 288 requires the same precision as navigating a large vessel. Its maximum speed is 0.76 kilometers per hour, slower than the average human walking pace. A full working day of travel moves at approximately 200 meters. The machine advances into the rock face, using the pressure of its own tracks against the ground. As the bucket wheel cuts deeper, the entire machine inches forward. To change direction, the machine executes a slow coordinated turn that takes hours to complete. The 12-track units are grouped into sets that can angle slightly, allowing the machine to arc through curves. The full turning radius of the Bagger 288 is approximately 100 meters, roughly its own length. When the machine needs to relocate to a new working area entirely, the journey takes days or weeks. In 2001, the Bagger 288 was relocated 22 kilometers across Germany. That journey took 3 weeks at maximum speed. 3 weeks to move 22 kilometers, slower than most rivers flow. The Hambach mine, where the Bagger 288 has spent most of its operational life, once had a very different landscape. Before mining expanded through the 1970s and 1980s, the Hambach area contained villages, farms, and forests. 12 entire villages were demolished to allow the mine to expand. Thousands of residents were relocated, homes, churches, and cemeteries, all removed. The Hambach forest, one of Germany's oldest woodlands, estimated at 12,000 years old, was 90% destroyed. The remaining 10% became the center of one of the most significant environmental protests in German history. In 2018, activists occupied the remaining trees to physically block the forest's planned removal. The German courts intervened. For the first time, a major lignite expansion was legally halted mid-operation. RWE announced it would preserve the remaining Hambach forest under public and legal pressure. The Bagger 288 did not stop, but the boundary it was permitted to reach was permanently redrawn. A single machine had forced a national conversation about what industrial progress is permitted to cost. The answer in 2018 was not that much more. The Bagger 288 was not delivered to the mine, it was built there. Components arrived by rail and road, the largest pieces weighing hundreds of tons each. Assembly took 5 years on the mine site, using cranes that were themselves among the largest in Germany. The bucket wheel arm alone took months to fabricate and lift into position. Every structural weld had to be inspected and certified before the next section could be attached. The electrical installation required kilometers of cabling routed through the machine's internal structure. When the bucket wheel was finally attached and spun under power for the first time, the vibration was felt hundreds of meters away. The machine was commissioned in 1978. It has been running with maintenance intervals ever since. Components have been replaced, control systems have been upgraded, but the core structure remains the original 1978 Krupp fabrication. A machine designed to last decades has outlasted the company that built it. In a single 24-hour period, the Bagger 288 removes 240,000 tons of material. That is equivalent to excavating a hole the size of a football field to a depth of 30 meters. Every single day. In its operational lifetime, the machine has moved more than 2 billion tons of material. 2 billion tons, loaded onto standard freight trains that would circle the Earth more than 30 times. The coal it has helped extract has generated hundreds of billions of kilowatt hours of electricity and released hundreds of millions of tons of carbon dioxide. Germany's energy transition, the Energiewende, has been progressively reducing lignite's role since 2010. The Bagger 288's operating schedule has been reduced as coal plants close. The machine that seemed built to run forever now operates fewer hours per year than at any point in its history. Germany has committed to ending lignite mining entirely by 2038. The Bagger 288 will not operate to that deadline. Its retirement is planned before the mine closes. A machine built to run without stopping is now running down. There is a second machine, the Bagger 293, built in 1995 and weighing 1,400 tons. The Bagger 293 currently holds the Guinness World Record for the largest land vehicle ever built. The Bagger 288 lost that record to its own successor by 700 tons. Both machines represent a category of engineering that was conceived, built, and may never be repeated. The economic and political conditions that justified machines this large no longer exist. No country today is planning a new bucket wheel excavator at this scale. The fossil fuel economics that made them necessary are being dismantled by regulation and market forces. The environmental opposition that surrounded their operation is now legally binding in most of Europe. What the Bagger 288 represents is not just a machine. It is the physical peak of an industrial era. The era when the only question asked of engineers was, can you build it bigger? The answer was always yes, at any cost, at any consequence. The Bagger 288 is the ultimate answer to that question. It stands 96 meters tall in an open-pit mine in Western Germany. Its bucket wheel has turned continuously for most of the last 46 years. 5 people run it per shift. 5 people operating the largest machine ever to move across the Earth's surface. When it finally stops permanently, there will be no way to transport it. The Bagger 288 is too large to be moved in one piece. It will be dismantled on site, component by component, the same way it was built. The largest machine ever to walk the Earth will end where it began, in pieces, in a pit, in Germany.